All right, sample problem 5.3 deals with Charles's law essentially, because Charles is the one that related volume and temperature together. So let's see here. It says a balloon is filled with 1.95 liters of air at 25 degrees C and then placed in a car in the sun. What is the volume of the balloon when the temperature in the car reaches 90 degrees C? So really quickly, I want to show you the relationship that Charles figured out with volume and temperature. This is the main thing we get from Charles's law. It's V1 over T1 is equal to V2 over T2. So what I have here is I have the first volume over the first temperature is equal to the second volume over the second temperature. So if we change, the temperatures, we can figure out what the new volume of these gases are going to be. Now, one key thing that I need to point out here, and this is super important, in order for Charles's law, and again, this is Charles's law, in order for this to hold and be true, temperatures have to be in Kelvin units. And notice in the problem here, they've given them to me in degrees C, so I cannot leave those in degrees Celsius. I have to convert them to Kelvin temperature. So that's going to be very important. But first of all, let's see. They're wanting to know what the new volume is. So I'm going to say that the new volume is V2. And I'm going to rearrange my equation here to solve for V2. Right? So I'm going to have V2 is then equal to V1 times T2, right? That's going to move up top, divided by T1 when I do my algebra. Right, I had to get V2 by itself, and how do I do that? Well, I multiply both sides by T2, and that gets rid of it in the bottom. So that's what I did to get to this step here. I just did some algebra down. Now I'm going to have to convert those temperatures, and remember, to convert from degrees C to Kelvin, we just have to add 273.15, and that converts from degrees C to Kelvin. So let's start plugging things in. So V2 is then going to equal V1. My first volume was 1.95 liters times T2. The car's temperature is changing to 90 degrees C. And so 90 plus 273.15 is equal to 363.15 Kelvin divided by our initial temperature, which was 25 degrees C, and so 25 plus 273 is going to be 298.15 Kelvin. All right, and check our units. Kelvin divided by Kelvin is going to be 1. They're going to cancel out. And this volume is going to be left in liters. So let's see here. I've got 1.95 times 363.15 divided by 298.15. And that's going to be equal to 2.38 liters for my new volume of the balloon after it sits in the hot car.